Now let me talk briefly about the ERT test.
So Sring, what is meant by ERT?
ERT is the electrical resistivity tomography. It is a technique that's used to extract the subsurface images.
Okay. So ERT seems very interesting.
Yes,
so if you could elaborate more on how we can extract the images from it.
So in ERT, the known amount of current is transferred into the ground with the help of current electrode, and correspondingly the voltage from the ground is measured with the help of voltage electrode. Current and voltage measured gives us the value of resistance, which is multiplied with the error factor K to get the resistivity. So now with the help of softwares, the resistivity value obtained can be used to get the ERT profile.
Sherab, if you could explain me about the setup, data analysis and computation.
Firstly, the apparatus used for this test are 3 energizers, main system, electrodes, measuring tape, wires and a. Now talking about the setups and the procedure involved for this test. Firstly, the electrodes are placed in a straight alignment using a compass so that we get a clear and accurate ERT profile. We have kept the distance of 50 meters for this test. Generally, for the arrangement of the electrodes, there are 3 array types, namely dipole-dipole, Wiener's and Schlumberger's method. For this test, we have used Wiener's array method, where 2 current electrodes A and B are kept at the end of the 2 sides. The potential electrodes M and N are kept in the middle, maintaining same spacing. For this test, we did it for the spacing of 5 meters, 10 meters and 15 meters. There are 3 energizers, and the wires in these energizers are connected in series. Now what this energizer does is, they distribute energy equally so that the load capacity is reduced. Now the wire from the 2 ends of the energizer is then connected to the main system. Lastly, a laptop with a software is connected to the main system for data computation. Now Sahil will explain about the data computation.
Today I'll be talking about how to create a table for your main system, and then how to collect the data using this software right here, GARM 1P for your PCs. First, what you want to do is you have to create a new table, and then for our setup specifically, it was the AMNB generic version, so we'll take this one and we'll take the measures number as 30. Just click OK here, and then this is the type of table formation that will be formed when you use it, so you'll get this kind of table. And you want to save this, and once you make your table, you want to upload your file inside the main system, and once you do that, you will have to follow this procedure right here in order to obtain the data for your area. So first, what you do is you have to turn on the ERT machine and then upload the file from our computer, which we did. And after that, we have to select the section measures and select measures option, and then we have to press enter. Once that is done, we have to select the file that was transferred from our computer to the main system, and then we have to select that and we have to press enter. Next thing we do is we'll switch on the 3 energizers so that we can compute and collect the data. After that, we have to select next measure and then execute options and then press enter. And then once we press the execute option, we will get a confirmation request, and then we have to confirm that request, and then the system will initialize recording. Once the recording is done, we have to investigate the sigma value to see if there is any errors. If the sigma value is 0, that means that your recording was correct or the data obtained was correct, and then you'll have to accept this measure by pressing the accept measure option. And then we repeat these options for all our area, so that we can get all the required data. The final thing we have to do is to do the data collections. That is to find how much number of measurements will we take for a specific length. So the general formula is n equals to t minus 3a by a plus 1, where a is the electrode spacing, it's the spacing between each electrode, and n will be the number of measurements, and t will be the total length of the site. So for the data we have obtained, for the first spacing, which is 5 meter, we get the number of measurements as 8. For the second, which is of 10 meters, we get the number of measurements as 3. And for the last spacing of 15 meter spacing, we get the n value of 1, which n value of 1.333, which is considered to be 1 because we cannot take a decimal value of data. So what does this specify? This indicates how many numbers of measurements can we take through for one spacing. For example, for 5 number of spacing in a 50 meter length, we can take 8 measurements, and so on. Thank you.
I will be presenting you the data analysis by using the software. First of all, we have to download the data from the main system. The download data should look like this, and from the downloaded data we have to extract R, that is resistance, to calculate the apparent resistivity. After extracting the resistance, we have to calculate the apparent resistivity by using the formula. Resistivity is equal to 2 pi V by I and A. V by I is equal to resistance that we have extracted from the downloaded data, and A is a unit electrode spacing. After that, we have to compute write down data in a node by using the Venner array data format. After that, following the Venner array data format. After that, we have to save the data in a form of DAT type. For example, for our case, and the file should be all type. After saving we have to open the software. We have to open the software and insert the data, that is DAT type. So for our case, it is 2EG DAT type. The reading okay, and we should carry out the inversion. Let me give the file name EG. Save, and finally the data analysis is completed, and it shows the subsurface image between the resistivity and the depth. From the analysis map, we can understand the materials present below the earth, that for our case it is in the football ground, below the football ground, with respect to the resistivity of the material.
Now, can you tell what's the significance of this ERT test?
After learning ERT test, its principle, working, setups, and the ERT profile produced, I came to understand that it is of much importance. I think it could be used in bedrock mapping. It is also used to find the minerals contained in the soil and to know the depth of the water level.
Wow, Shaita, that's so impressive of you. So after knowing the properties of the subsurface, we can know if a particular construction is feasible over that particular land. So that's the significance of ERT. This is group number 3, and I hope this video was useful. Thank you and happy learning.